Hello again and welcome to our next video which is about how to make up a solution, and we'll be going through a number of steps such as weighing out and how much to weigh out, how to transfer the solid, how to make up the solution and to get an accurate volume. This is something that you'll have to do a number of times in the laboratory, so it's an important skill to get used to. Okay, for this example, we're going to weigh out a solution of 0.1 molar potassium permanganate, and we're using this one because it's a deep purple colour, so it's easy to see the transfer of the solid and the solution as it's being made up, which you'll see in the video. So, how do we know how much to weigh out? Well, on the side of bottles of potassium permanganate and other solutions, the molecular weight will be reported. If for some reason the molecular weight isn't reported, you can look up on a website like Sigma and get that value. The MR, or molecular weight, of potassium permanganate is 158.04. So how much do we weigh out? So we need a 0.1 molar solution, and this equation triangle tells you how to convert between mass, moles and molar mass, or molecular weight. And so we use this part of the equation. So the number of moles times the MR equals the mass that we have to weigh out. So it's 0.1 multiplied by 158.04, and that gives us 15.804 grams. Now that is assuming that you're making up a solution of 1 litre. However, in this example we are weighing out half that amount, 500 millilitres, which is half a litre. So we divide this 15.8 value by half, and we get 7.902 grams. The process is exactly the same when you weigh out your solutions. You use the moles and multiply by the MR, you get the same, but remember this first calculation relates to 1 litre, so then you have to make allowances if you're doing a larger or smaller volume. And so the next part of the video will begin showing you how to weigh out the solid and then how to make up the solution accurately. So we're now going to weigh out the potassium permanganate, and you can see that we're using a balance. All balances have similar functions. One of the most important ones is this one here, which is sometimes called the TARE button, T-A-R-E, or 0. In this case it's a 0 TARE button. And this is when we can place a weighing boat onto the balance and set the mass to 0, which then allows us to weigh out our solution of potassium permanganate. So bear with me while I do this. It's important to not rush and to weigh it out carefully. So we're almost there now. So I'm adding a bit more slowly now towards the end to make sure I don't add too much. And we are almost there. This is a relatively large amount we're weighing out for the purpose of the demonstration, but it is possible that you could have to weigh out this much, or even slightly more than this, or you might be weighing out a very small mass. So, for the purpose of the demonstration, that's fine. And the next step is to transfer into the beaker. So we do that as carefully as possible. And we've used potassium permanganate in this example. because it's dark purple crystals, so you can easily see, and you can see some of the solid is still on the weighing boat, so we use distilled water. This will all add up to the final volume, but for the washing step it's fine. The advantage of potassium permanganate, it's very easy to see whether all of the solid has been rinsed because the purple solution, but of course with your solution it may not be as easy, so you just have to be as careful as possible. So we've transferred the solid and done some washing into the beaker, and it's important to allow the solution to dissolve in a smaller volume in a beaker before we transfer to the volumetric flask. And partly the reason for that is your solution may need some adjustment, such as pH adjustment, so it's important that you make it up at a smaller volume first to allow it to dissolve. Now this solution dissolves very easily for the purpose of the demonstration. However, your solution may need some time to dissolve, and a good indication of that is if you can see particles still in the solution, and so it may need to be stirred or put on a magnetic stirrer plate. But you can see that here it has dissolved, and now the important stage is to transfer into the volumetric flask. Also, by not using up the total volume, I can wash this beaker out and transfer into here. Now this is a very dark solution and it's stained, so I need to be careful and use a funnel. I'm not always the tidiest of people, so I need to be careful at this stage. So of course we use a funnel, and it's important to add it slowly. If you add it too quickly, then it may rise up the funnel quicker than it can go through the other end. And then the other stage at this point is to make sure that we wash the beaker out. And of course with this demonstration we know if that's occurred, because there should be no purple solution left in the beaker. And so it may take a series of washes. Now you are not necessarily going to know if this has been successful with yours, because it may be a colourless solution. So my advice is just to rinse as many times as you can until all of the solution has been transferred. So we'll now skip to the next part where I show it making up to a final solution. Okay, so we've now moved on. The beaker that I was using before has been fully rinsed into the volumetric flask, and now we can make up to the final volume. Of course, you don't want to ruin all your hard work at this point by adding it too quickly and it going past the line, so it's important to do this slowly and to use a funnel if you think it's required. So we're just going to add a bit more water. Apologies for the noise. And you can see it's starting to get to the neck, the narrow part of the volumetric flask. Now volumetric flasks are very accurate if used properly, because there is something called a meniscus, and I will just rinse the sides to make sure the purple solution is all below the meniscus. Now, the meniscus is just at this line here, and it's important that we add the solution slowly and get at eye level. Otherwise we can have something called a parallax error. And what we're looking for with the meniscus is you will see a curve at that point of the liquid, and it's where the curve, the bottom of the curve, must touch the line. So it may look like the sides of the solution have gone slightly above the meniscus, but it's the bottom curve that needs to touch the line. And that is now made up to solution. It's always a good idea to put a stopper on and to invert a couple of times to ensure a homogeneous solution. And that is your solution ready. And then of course you would label this volumetric flask and store it in the appropriate way. Okay, well thank you for watching this video, and I hope if you haven't checked out the other videos that you will check them out as well, and I hope you've had almost as much fun as I have, which is quite considerable. Okay, see you next time.